unit for quarter 4. So everyone has this packet and the homework packet, right? So it says up at the top, exponential functions provide excellent models. I'm just reading. You can read along, Emma. Thanks. For physical, biological, and financial situations in life, there's a lot of applications. So investing money, that's exponential. Population growth, that's exponential. The difference between linear and exponential, instead of like adding $5 every month, you're multiplying by an interest rate, or your population of bacteria might double every hour. So you're multiplying instead of adding. I feel like we'll see that that's a big idea. If you kind of look at the time ahead of us, if you notice on Monday, that's when we're going to start assigning the homeworks, because they're all going on quarter 4. So unit 4 in the catapult, they're all going on quarter 4. The last thing in Power School is unit 3 for quarter 3. If you notice, next Friday the 14th, we're going to spend the first half of the class doing a quiz review together, and the second half of class doing our first quiz on exponents, like the things that we've learned to date. Okay? And if you notice, next week on Wednesday, you have an early release. Look forward to that. All right, so I wanted to show you this introduction page of the resources. So what is an exponential function? If I shut the light off, can you see it better? So an exponential function just has the x located where? In the exponent. That's why it's called an exponential function. The x is in the exponent. This is not an exponential function. What kind of function is that? We just studied that. That's a quadratic. Yeah. This is an exponential function. See how it's a little bit confusing? They both have a 2. They both have an x. This one's called quadratic. X is being squared. This one is called exponential because x is in the exponent. So this is also exponential. So I feel like that's kind of a big idea of just recognizing, what is an exponential function? Okay, so the first kind of task that you're going to need to be able to do is just evaluate using order of operations with some smaller numbers. We need to get better at our mental math skills without relying on the calculator. So the first thing you have to do is parentheses. Let's look at number 1 together. What would I do first? 2 plus 3. You all know that that is 5. Now, here's the biggest mistake. People want to multiply 5 times that 5. You don't. Exponents comes next. So the only thing getting exponents is this guy. You do the 5 squared. So now you do 5 times 25. And if you have 5 quarters, how many dollars would you have? Or how many cents would you have? 5 quarters makes how much? 125. So I think those are all small enough numbers we could do a problem like that without the calculator. I want to draw your attention to example 2 and example 4 where I drew the arrows. What's the difference between example 2 and example 4? They both are negative. One of them gets a parentheses, one of them does not. This is a big mistake that we made in quadratics with like taking b and squaring it. If it's in parentheses, it becomes positive because it's negative 3 times negative 3 is 9. I'm going to do example 4 first. 9 minus, what is 2 times 3? 6. And what is 9 times 6, or 9 minus 6? 3. Now, in number 4, I said negative 3 times negative 3 because it was in parentheses. In number 2, the way I read this problem is the opposite of 2 squared. So you're really taking negative 1 times 2 squared. The negative doesn't get to be part of this exponent. So you end up with negative 4 instead of positive 4. And that is confusing. When it's inside the parentheses, you're squaring the negative number. When there's no parentheses, it's the opposite of 2 squared, which is just regular negative 4. Now your calculator knows this, and that's why when you guys were plugging in stuff for quadratics without parentheses and you were just doing -2 squared, your calculator told you -4. And when you did in parentheses -2 squared, your calculator said +4. In the parentheses, it's getting squared, right? Yes. Okay, and then example 3, what order of operations should I do? Parentheses first, so this is a 1, 3 plus 1, this one's a 4, and I'm squaring it. And then I do 4 squared is 16, 1 times 16 is still 16. Okay, so that is evaluating by hand. Part 2 is using function notation. We don't do this enough. How would I figure out f of 0 in this first example on number 2? This is the function. What do you think f of 0 wants you to do? Put the 0 where? In for x. 2 to the 0 plus 1 minus 3. So I'm plugging in the 0 over into this function. If you needed to use a calculator, you could. What is 2 to the first power? 2. And what is 2 minus 3? Just -1. Now you try plugging in 3. Okay, good. So plug the 3 in this time. So that'll be 2 to what power? 3 plus 1, which would be 2 to the 4th. You could use your calculator, or you could do 2 times 2 times 2 times 2 in your head. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th is 16. And then what's 16 minus 3? Okay, so lots of mental math. I know you guys can do it. We just need to up our mental math game. All right. I want you to circle on part 3. The exponent key on the calculator is the upside down caret symbol, in case you don't know where that is located. I want you to type this into your y equals menu, and I want you to use the table on this problem. Some of you don't know how to use the table on your calculator. I'm going to show you. Go to y equals, clear out whatever's in there. Probably someone already typed this function in, so clear it. Type it in for yourself. Go to the y equals menu, clear out whatever's in there, so you have to type it in yourself, and you're going to type -300 times 0.2. I'm doing the function that's right on your page. Caret symbol to raise it up into the exponent, raise to the x, arrow over, and I need to do a -3. So that's the, we're trying to use the table. That's the negative symbol, this is the coefficient. That's the minus symbol. And did everybody get it to show up in the exponent? To go to the table, I always like to hit table. See how it's above the word graph? If it's not in the right place, you might have to hit table setup, which is above the word window. Second table set. Oh, whoops. Oh, I started at 10. I need to start back at like 1. Yeah. Second, and then the graph gives you the table. Second graph, table. Did you get those numbers to show up? If you didn't get those to show up, so you could just write your answers down on the table, I should help you get to the table. Oh, wait. You're doing it on your table. I don't know what you're doing. Yeah, -75 with 3. That's the right one. Yep. How do you go back down? Oh, arrow to the right. Okay. You jumped all the way to 20? Okay. Did you get the table to show up? Yeah. Did you put the table to show up? You know how to do table already? Are you feeling okay? No. You're answering from your phone? You just don't look on yourself. Usually you're doing better, I feel like. Are you going backwards? So I had negative 7503, negative 1503, negative 303, negative 63, and then if I go all the way up to 20, did you need help from the table? And I'm going negative 3, out negative 3. If you actually put your cursor over the negative 3, you'll see a decimal approximation. So why is this about negative 3? We're going to learn that it's not exactly negative 3. It's going to be important later. Oh, so see how this just doesn't give you the decimal? It's not exactly negative 3. We're going to learn that our graph approaches but doesn't touch negative 3. It's called an asymptote on the graph that we'll see later. Okay, so did we all get the table? At last call on the table. Because the one other piece I wanted to show you today was scientific notation, which I feel like we used to teach in science. Like if you're taking chemistry, maybe you've heard of the mole, 6.23 or something times 10 to the 23rd, right? No? Or if anyone's in metals, like you have to be exact to 0.0001, 1 times 10 to the negative third power or 1 times 10 to the negative fourth power, but we don't use scientific notation a lot. So the rule for scientific notation, it's just a way to express big numbers easier. So instead of saying that the distance to the sun is 93 million miles, we can truncate the number between 1 and 10. Is 9.3 between 1 and 10? Yes. And then we're going to write times 10 to a certain power to move the decimal all the way back over to 93 million. So if I put my little dot with my purple pen where 9.3 is, and I think about sliding my purple pen all the way to the end, how many times does it have to slide past all those zeros? It has to slide 7 times to the right. So you go and you say, okay, 9.3 would be here. 1, 2, 3, 4, 5, 6, 7, 7 decimal places to the right. Or you can count up how many zeros you have and how many numbers you have. So what would the next one be? How do I truncate 3.23? And times 10 to what power? So think about how many times will you swoop your decimal point to go to the right? 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 8th. Yes. Has people seen this before? Now we're going in the other direction to make a very small number. I still truncate the number the same way. Between 1 and 10, what number would I use? On number 3, I have to pick a number between 1 and 10 to represent that 0.0027. So I want to use 2.7 times 10. How many times do I have to go? I start at 2.7 and I think about how many times do I have to go backwards to the left? So you can count the 2 and then 1, 2, 3, 4, 5, 6, 7. I think there's only 8 at the decimal point. That extra 0 in front of the decimal point doesn't count. You just need to get back to the decimal point. Okay, what about 365? 3.65 is between 1 and 10, and I'm trying to make my decimal point go bigger to the right. So times 10 squared. All right, now we're going to take a stab at changing from scientific into regular notation. So the 3, 6, I just start by writing my 3 and my 6, and if I swipe to the right, 6 spaces, what I do is I think, okay, this is my first space just to get to 36. I've already used up one of them. I only have 5 more to go, so I need 5 zeros. Right? The 6 plus additional 5 zeros would be my 10 to the 6. Then I like to go back and make sense of the number. This would have been like 3,600,000 if I put my commas in. All right, and then if you're going in the other direction, you're doing your 3, 2 backwards, you would do one kind of swipe to the left, use one of them. To go -5, I would need 4 more zeros in front of the number, right? 1 puts me to the other side of the 3, and then 4 more zeros. So that's a really small number. The negative makes it a small number. And then how would I write number 7? It always is just a positive. It's just a decimal that's moving. So make sure you wrote it as a positive 0.68. That's it. Okay, and then I want you to write, because some of you are going to use this in science. This is kind of like nice to know, this shortcut for scientific notation, but I'm not going to test you on this. I'm going to test you on the top part. There'll be a scientific notation question on the quiz. But a shortcut that's nice to know is that you can just multiply 1.8 times 3.6 and ignore all the tens for now. So what is 1.8 times 3.6? Especially if you might go into some sciences. Be nice to know. This is 6.48 times 10 to the 7 zeros altogether. This guy had 5 zeros. This guy is contributing, multiplying by 2 zeros. So you would have times 7 zeros altogether. So the 5 plus the 2 makes it a 7. Okay, and then the last one, what do you think? If you can multiply, you can actually divide these numbers and just do the 4 divided by the 2 is 2. And if you've got 12 on top and you're getting rid of 3 of them, you're really doing some subtraction. You're canceling out 3 of the zeros. So you would have times 10 to the 9th. Same thing on number 10. You can take the 6 and divide by the 2, and that would give you 3. This one's tricky. If you did 12 minus 3 over here, you're going to do -6 minus -8 over here. What's a -6 minus a double -8? It's really -6 plus 8 would be 10 to the 2nd. -6 minus -8 is 2. And that's where I'm stopping